we know that cavitation is a problem. We know the causes of, we know the effect also that it has. The damage it can create is actually quite significant over the time. Okay?
Yes.
So the erosion failure, the pumps, the centrifugal pumps, for example, that we have observed in condensate lines, they actually need to be replaced every 2-3 months. The frequency is that high.
Actually, it's maybe 15 days.
Okay.
and the failures that they see is, there are multiple reasons for failures, because first of all, seals will fail. Then you will, if you ever get to see a pump which is pumping a condensate near its, which is operating near its boiling point, you will also hear sounds like there is sand flowing. Sound like that.
Yeah.
So that is nothing but small bubbles getting formed and bursting.
Right.
So, and it's something to, if you witness it, you'll know that your pump is going to fail.
Yeah. Right. There are warning signs coming into the picture.
Okay. And you will also see this happening. See, if it's a cold start, I'm not talking about pump, I'm talking about valves. If the valve is supposed to handle only, let's say, single phase, let's talk about gas. So the steam is supposed to flow through a valve, but during cold start there is some condensate that comes out, and after the valve you have a trap to remove the condensate. So initially a cold water will flow through the valve. You won't see anything. I mean, it will still be in liquid format throughout the moment. This water is backed up with steam. So you will start seeing increase in temperature. The moment there will be a phase when through the valve, after the valve, you'll hear the same sound during the startup. So cold start. So what happens is this water has now reached its state where this side is pressure. Before the valve there is high pressure. After the valve there is low pressure, and this water is near its boiling temperature at its higher pressure. The moment it crosses the valve, you will start hearing this sound. This will be very small. It won't have catastrophic failures as a regular cavitation scenario, but that is again same thing that is happening. So water at high temperature flowing through the valve. There will be bubble formation, and these bubbles will collapse the moment it enters into high pressure. And I think your next question was how do you prevent this?
Yes, that's what I was looking for. Yeah.
So. In centrifugal pumps, there are some rules given. Your net positive suction head should be 3% of the actual. There is available suction head and required suction head, and available should be 3% higher than the required suction head. So there are some definitions done to make sure that the pump never fails. But in valves, cases where it cannot be avoided, like there are cases where you have to make sure. You have to make sure that liquid will flow from a high pressure zone to a low pressure zone through a throttling device. In that case, these valves, so the seats and the stem of the valve is designed accordingly. Okay. So there are multiple ways of doing it. It's not just one. So maybe 3-4 ways of doing this. So one would be, if it is allowed, but that is mostly it won't be, but if it is allowed, you can add on another media which has the capacity to expand and take space in the zone which is formed, in the bubble zone that is formed.
Okay.
What benefit it gives you? But most of I think 98% cases you will see mixing of two different phases fluids is not
a good idea. Yeah, I know.
But it will stop cavitation. If cavitation is a main concern and mixing of fluids is still okay. If let's say it's exposed to ambient later on and you're okay with some air mixing into it. If you just put a hole there, put a tapping there through the ambient, if this is going, it will start sucking air and it will allow, it will fill in the gaps and then the bubble will not be able to collapse. That space is being taken. Right. So the negative pressure that is created and the bubble that is formed, before it gets leaked out, you fill it with some other material.
Right.
Not recommend. I will not say that. We can never do that in steam systems because we don't want any mixing.
But because it is going to create an additional layer, basically, of water, of air in this case.
We don't want that happening.
I think we face some technical difficulty.
That's it.
You can ignore that. Yeah. But that added air is again a difficult headache to remove.
Easiest thing to understand, which is why I said that. then there are certain things taken care of. I mean, certain things done to take care of the effects of cavitation. So maybe what can be done is, or what is done in most of the cases is, the locations where there will be bubble impingement and there will be failures, there are hardened liners provided in the valves. I'm not talking about pumps, specifically for valves.